Today's topic is all about scope. So what is scope? It's all about the accessibility and the lifetime of variables in different parts of a program. Understanding scope is crucial because it defines where your variables live and what can interact with them. I'll break down what scope is, how it controls access to variables, and why it's important to writing clean, efficient code. By the end of the video, you'll have a good understanding of how scope works, and you'll be ready to start applying these scope techniques in your own programs. In this video, I use a function written by TradeStation to print the contents of a collection. It's on my GitHub page in the EasyLanguageCoach.ELD file if you want to download it and follow along. You don't have to import everything in the ELD file. I'll list what you need in the description below. This image shows a visual representation of scope boundaries across a program. Local scope is indicated by the blue box here. It has a local parameter called parm and a local variable called z. Only code inside the method can access its parameters and local variables. Now, once the method exits, these parameters and variables are no longer available. And when this happens, the variables are said to have gone out of scope. The next level scope higher is module scope. The module level scope is indicated by these yellow boxes here and here in the indicator, and then over here in the function in this yellow box. Now, these are two separate documents. One is the indicator, one is the function. So the scope does not transfer across this boundary until we get to global scope. Inputs like X and variables like Y are defined in the module level scope. Code in a once block and any code below it also falls under module level scope. And this is the scope you're probably most familiar working with. Variables at this level are accessible as long as the app is running. The last scope level is global scope. Now, I consider app storage to be at the global scope level. Some may differ with me, but that's fine. It has the widest scope, allowing any indicator, method, or function that references it to be able to add, update, or delete pairs inside of app storage. And the values inside of app storage are available until they are cleared. The takeaway from this is that as scope widens from local to global, variable access increases, but so does the potential for unintended interactions with those variables, which can lead to complex code, things that are hard to debug, and unintended consequences. Okay, let's have a look at some code. Here I have a small snippet of code. It contains an input, a couple of variables. We're going to clear the print log and then print X and Y. Now, this is all module level scope, so we're trying to print X and Y in module level scope from module level scope, so this should work. Here we see 1 and 2. The next thing I want to show you is local scope. So we're going to do that with a method called foo. It returns nothing. It has a parameter of parm and a local variable defined as z. We're going to try to access the module level scope of X and Y inside the local scope of foo. And we already know this works, so let's get rid of that. We'll make a call to foo, pass it 4, and we can, in fact, access module level scope from local scope. Okay, let's look at accessing internal parameters and variables from within the local scope. We're going to set z equal to 3, and we're going to print z and parm, and we'll get rid of that because we already know it works. So over here, we've printed the 3 from z and the 4 from parm that we passed in here. So that seems to work. So let's look at how a module can't reach local level scope, which is this z and that parm. So if I come down here and I type print parm, here's a tip. If autocomplete won't find the parameter or the variable, then it's not within the scope. When I type m, it doesn't find it. So let's just verify that. So now we have an unknown identifier, which is what we expected. So from this module level scope, we can't reach inside of this method and look at this value or z. So let's try z now. I don't see z show up on the list. We'll try it. We get unknown identifier. So let's remove that. Module level variables can be accessed from local scope, but local parameters and variables can't be accessed from module level scope. The key takeaway here is that variable access is broader in higher level scopes and narrower in lower level scopes. The point I want to drive home is local variables are protected and they can't be changed by other areas of the program. when you push variables into the local scope and keep them out of higher level scopes like modular or global, this is a good defensive programming practice. Something I mentioned earlier about methods is the variables declared in them don't persist their values across multiple calls. So let's take a look at that. So the first thing we're going to do is we're going to look at the initial value of z. Z comes up 0, and we're still printing 3 and 4 for the z value after we've assigned it and the parm of 4 being passed in. Let's call foo again with the value of 5. Now notice here, when we ran it, z was initialized to 0, then we set it to 3, and then we printed the parms. So 0, 0, 3, and 4. When we called it a second time with 5 here, we still got 0. So this shows that z did not persist its value across multiple calls to it. What if we add intrabar persist to this variable? Let's verify that. Now it says identifier expected. This was to be expected because you can't use intrabar persist within a method. If we set a variable in the method and the method exits, the variable goes out of scope and the variable is no longer accessible. When the method is called, it sets up a new instance of the variable, so it can't persist the value across calls to it. If we want to persist the value of a variable across method calls, we'll have to declare it at a higher scope level. Now let's say we want to persist this z across calls. So we'll define it at the module level. And we'll set the value to 10. Verify that. Get rid of this print z, clean up the code a little bit. Let's update that line and print the local value of z. And we'll also print module z. Let's verify that. Okay, so here we have a 3 for the local z and 10 for the module level z. So how did that happen? That's because we got 2 different instances of z, one in local scope here and the other in module level scope here. But how did EasyLanguage know which variable to set? Well, it's all based on scope. And so the program follows a rule called scope hierarchy or scope resolution, where local scope takes precedence over module level scope. That's why this variable was set to 3 and that one was set to 10. The assignment of z went to this variable, not that one. If we intend to set z at the module level so another part of the program can use it, we've inadvertently created a bug by doing this. Setting z inside the method didn't actually set z at the module level, even though that's what we wanted. Now, just looking through the code, we have z here, we have z here. We were printing x and y before. So even though this is a small program and we only have a few variables defined, the code is rather hard to follow. And this is where a naming convention can really add readability and understandability to the code, as well as reduce these types of errors. So I have another video called Benefits of a Naming Convention. That video ties in really nicely with this one, and I put a link to it in the description below. Okay, let's clean up the code using the naming conventions in that video, and then we'll come back and take a look at the code and see what improvements it made. I'll start here with my input, so I will label that with an I. That's pretty standard. I'll come in here and do this. I go up from the bottom because IntelliSense gets in the way if I go from the top down. This parm is a lowercase p. These are m for module level variables. My local variables inside of a method, I just try to keep those short. So we'll have to change the parm here. We'll come back to this z here. And then this one is going to be mz here. Let's verify that. Okay. Our intention was to use a variable at a higher level scope to preserve the value across calls. But when we look at this print statement right here, this z, we don't see the module level one up here. So this tells us right away that we're not using the right variable. So this is how a naming convention can really help out. So let's get rid of this because we're not going to need it anymore. I'm going to change this to update the module level variable. And what we're going to do is we're going to add the parameter value to the value of mz. And then here we're going to look at mz. We're going to call this a couple of times down here. So we're going to print mz. At first it should be 10. Then we're going to add 4 to it. That should bring us to 14. Then we're going to add 5 to it. And then it's going to be 19. And if we get that type of progression across the calls, then we know that we're persisting the values across these method calls. So let's verify that. Let's get rid of this. Okay, so it was set to 10. We added 4 to it. We got 14. We called it again with the initial value of 14. We added 5 to it. We got 19. And then we printed the last value of it here, and it was 19. So we can see referencing this module level variable inside the method allows us to update this value. What I've shown here is the lifetime of a variable in a method is too short to persist any kind of value in it. So in order to get variable persistence, we had to use a variable declared at a higher scope level. Now let's look at some of the improvements the code cleanup did for us. Okay, let's give the code a quick rundown. So all of our inputs are defined with an I for an input and M for module level variables. Our parameters start with a lowercase p. We know that this is a module level variable that we're accessing inside of a method. Here we know we're using a parameter from it. It didn't come from anywhere outside here. This is very definitive because we know we're using a module level variable here and an internal parameter here. And then down here, we're using things that are in the module level scope. So looking through the code, it's easier to read due to the prefixes. We can look at a variable and tell exactly what the scope is, and we know the lifetime of the variable as well. Now, before we had prefixes on them, it was hard to tell what their scope was. Now, when we start working with larger programs, we may have to keep track of several module level variables when working on a bug or just developing the code. Keeping variables local gives us less module level variables to keep track of when we're doing things like debugging or trying to walk through the code in our head. All right, now the last and most visible scope level is the global level. And app storage is a dictionary that's on the analysis technique like an indicator. And a dictionary is basically a data structure that stores data in the form of key value pairs. Now, each key in a dictionary is unique and it maps to a specific value. So any function called by the analysis technique, such as an indicator, can access, modify, or even add a key value pair to app storage. So let's clean up the code and take a look. Let's just strip it down to bare bones. And we'll add these 2 lines. Okay, let's go ahead and run that. All right, so basically how this works is app storage is a dictionary, and it uses square brackets for the key, which here is a quoted string literal called order ID. When setting app storage to numeric values, it's best to actually type them going in. So 10 is an integer, so we're going to cast this as type integer. We always have to cast the value when retrieving the value from a collection like a dictionary, using as type and then the type. So in this case, we're going to cast what's in order ID to a type of integer. So let's go ahead and change this to 20. So we put that in the dictionary and then we read it back and it looks like that worked. Okay, let's try to print the app storage value from the method. So we get 20 twice here. We'll set this back to 10. And we get it twice. Because app storage is available at the global level, we can actually change the order ID inside the method as well. So let's print app storage after we call it. So we came through here, we set it to 10 and we printed it. So that's the first 10. Then we printed it inside the foo method and that was 10. And then when we got out of foo, then we printed it again, and that was 30. So we set it 30 here, and then we see that it changed to 30 here. There's a great little function TradeStation wrote to print collections called ELC print collection. You can download it from the GitHub page listed in the link below. And this is the function I was telling you about earlier in the video. So let's add that. Let's verify that. Let's walk through this function real quick. So the function name is ELC print collection. It has 4 parameters. The first parameter is what you want to print. So if you had orders in here, you would change this to orders. If you were looking at positions, you would use positions. We're just looking at app storage, so I'm just going to use the app storage name. So it prints app storage here. So whatever you put here, it's going to put in front of it. That way, if you're printing multiple collections, you'll know what collection you're actually printing. So then the next thing you do is you give it a parameter of what is the collection you're printing. In our case, it's going to be app storage. This has to do with indents. We're going to start with 0 indent, and then anything that's hierarchical, we're going to indent by 3 spaces. And if we look over here, the K is the key, which is order ID, and then the value is 30. So we're going to look at how app storage interacts with a function. And I have a function defined here. So we're going to put this on a new vertical. So if we go back to our image, we see that we've already covered module scope. We've covered local scope. We've seen variables interact here. Variables from local scope can access things here. But what about interacting with a function? Earlier, I said that global scope includes methods plus any functions that are referenced by the indicator. So in this case, we're going to go ahead and call this a visual guide to scope function, and I'm going to show you how to pass app storage values into the function. So the first thing we should do is clean up our indicator code. So the first thing we'll do is call the function. We won't use foo anymore, so we can get rid of that. All right, so we're going to verify that. We already know that all of this stuff works. We're going to clean that up. We don't need this because we now have this fancy dancy function from TradeStation. All right, so now all we're doing is just printing the key and the value from app storage. Let's also get rid of this since we're not going to need it anymore. All right, now we're down to just bare bones. Let's add some code and I'll show you how I use app storage for global settings. Okay, so we have this variable called print messages up here. And what I'm going to do is I'm going to put that into app storage. Now remember, this is a dictionary, but we didn't have to cast this because we're only casting numeric type variables going in. This is a Boolean, so we don't need to cast it. But when we pull it out on the function side, we're going to have to cast it. So I'm going to go ahead and run the code, and we're going to add print messages into app storage. So we have the existing order ID that was in there, and we also have its value set to 10. But now we see a new key show up, and its value is false. Now notice, I stripped out the order ID information from the code, but it still exists in app storage. So if you remember from the beginning of the video, I mentioned that the retention value of the values in app storage are there until you actually clear them. And so this is showing that that's true. Okay, before we add the receiving code, let's bring our code up to the naming convention standard I use. Add I there, M there, and we'll drop some code in here. So let me explain this. App storage has a method on it called contains, and that checks to see if this key value exists within app storage. If it does, then what we're going to do is we're going to pull the value associated with the print messages key, and we're going to type it to a Boolean data type, and we're going to assign it to mprint messages. If mprint messages is true, then we're going to show debug enabled down here in the window. So let's go ahead and verify this. And we'll verify this. Now let's change this to true and see if we get the debug enabled message down here. Okay, it worked. Now I use app storage for global settings that I don't want to pass as a parameter to functions. One thing to note here is I didn't create a new parameter in the function or use iLength. I have a lot of functions that have logging in them, and I use app storage to enable and disable the logging messages across many custom functions. When I set this to true or false, it enables or disables the logging in all of the functions that are referenced from the indicator. This is how I kind of use it as a master control switch. The last thing I'm going to show you is how to clear app storage. We do it with a clear method on the app storage dictionary. Let's verify that. So if I clear this and run it, we'll see now that the order ID is gone, and now we just have the print messages in the collection. Okay, let's look at some best practices. What I like to do is keep scope as tight as possible and open it up as needed. That means I will put as many local variables into methods as I can. Or if I need to persist values across method calls, then I will put those values at a higher scope level. I always favor local variables over higher scope variables because it keeps them local to the method. There's less chance of them getting changed by something inadvertently. Define the variables closest to where it's used. Pass parameters to methods to maintain clean, predictable code. Use a naming convention to reduce chances of name shadowing. And limit the use of app storage to global configuration settings instead of just throwing everything into app storage. By using these best practices, this should improve readability of your code. It will encapsulate logic inside of a method. It should reduce bugs. It makes code easier to debug. And overall, it keeps code well organized and easier to understand. Now, the point I really want to drive home is that local variables are protected and can't be changed by other areas of the program. Now, this is a good defensive programming practice. If we have a bunch of higher scope variables that are in use by multiple methods and are passed around in multiple functions, this opens up the code to complexity and vulnerability. So proper scope becomes crucial when working with larger programs. I like to keep the guts of the method on the inside of it and not on the outside. Well, that's all for this one. If you enjoyed this video, be sure to give a big old press on that like button. Share the content with others that may benefit from it, and don't forget to subscribe if you'd like to be notified when I release new content. Leave a comment below how this video helped you tame variables in your projects. Thanks for watching, and I hope to see you in the next video.